Every year, the Department of Energy's Office of Science asks all of their labs to define a long-range vision for the future. The defining challenge for Oak Ridge National Lab is energy. Energy broadly defined, bringing together both the economic, the national security, and the environmental impacts of our choices in energy generation, distribution, and end use. There's a very tight linkage between energy use and standard of living, or GDP. There's also a very tight link between energy use and CO2, because about 80% of our energy comes from fossil fuel. We have lots of technology options at our disposal today that can help with that, but none of them are sufficient to get to where we want to be 20, 30, 40 years from now. So how do we create a world where a larger fraction of the world's population can enjoy the same standard of living that we currently enjoy in the US, but not get into intractable conflicts over declining resources or unacceptable environmental consequences? Well, the solution has always been improvements in science and technology, and that's why Oak Ridge National Lab is here. What Oak Ridge National Lab brings to the energy challenge is really defined in our mission, which is deliver scientific discoveries and technical breakthroughs that will accelerate the development and deployment of solutions in clean energy and global security, and in doing so, create economic opportunity for the nation. More so than any other laboratory in the world, we have a span that goes from very fundamental science all the way to more application-driven R&D. There are 4 broad areas that we have to be really, really good. Neutrons, computing, materials, and all aspects of nuclear. And there's 3 reasons why we do things. Because it's transformative science in its own right, because it affects the energy mission that I talked about, or because of the implications for national security. Although there's a lot we can do with currently available technology, major advances in basic science and supporting technology are really needed to ensure success in transforming our energy landscape. Oak Ridge is fortunate to have 2 of the world's leading neutron facilities. We use neutrons to understand materials, where the atoms are and how they move. That understanding impacts our ability to deliver on the applied missions. It always has, with high temperature materials, some of the underlying technology of the information revolution, or the discovery and the development of new pharmaceuticals. If we know that, then we can design materials that perform better, that are stronger, that last longer, that don't have some of the unintended environmental consequences, or that just make new things possible. Another leadership area for Oak Ridge is computing. We need to sustain the world's most capable complex for computational science. It's not just the machines, it's the infrastructure and the people, the ability to do modeling and simulation at a scale and with a precision that's unmatched, the ability to handle huge volumes of data and pull out of it understanding. Modeling and simulation provides the bridge between experimental data and our theoretical understanding. Whether it's modeling materials, biological systems, fusion reactions, or nuclear reactors, we can use computers to go places that experiment can't. We got into computing because of the science we do, but one of the really exciting opportunities is taking high-performance computing to real-world engineering problems. We've been able to apply modeling and simulation to the design of turbine blades to improve the fuel efficiency of jet aircraft, the airflow around heavy trucks, and the 104 reactors in the light water fleet that provide 20% of our electricity today. Working with industry, we can take this tool that we developed to understand exploding supernova and the evolution of climate models and apply it to things that will impact employment and economic development for years to come. Materials has always been something we've done at Oak Ridge National Lab, going back to the very beginning. The challenge now is to develop and deploy advanced materials for energy applications, and at the same time advance our understanding of the fundamentals of chemistry, condensed matter physics, and structural biology. We have terrific tools to study materials. It includes our neutron facilities and our supercomputers, but it also includes what we do in synthesis, the Center for Nanophase Materials Science, and some of the translational research we do in partnership with industry. It might be low-cost carbon fiber or titanium. Could be coatings that are hydrophobic, or novel energy storage materials, batteries and capacitors. Those are jobs that won't be easily moved overseas because they're tied to the people and the understanding that's been developed around them. Weinberg used to say, and this is paraphrasing, fundamental research done in an application-rich environment has an edge that you can't get any other way. And applied research done in a science-rich environment has a toolkit that's irreplaceable. We want to apply our signature strengths in neutrons, materials, and computing to resolving critical scientific and technical issues for advanced nuclear energy systems. Whether it's the challenge of ITER, an international undertaking that'll resolve the remaining scientific questions around fusion, or a nuclear fuel cycle that deals with waste and does so in a sustainable way. So it's fuels, understanding materials, understanding the performance of nuclear reactors, using things like our supercomputers, gives us an important role to play in answering some of those problems. With our hot cells, our reactor, and the people around them, we can contribute to the isotope mission. Isotopes for research, isotopes for exploration, or new ways of imaging and treating disease. Transforming the global energy system requires progress on a number of fronts. There is no single point solution. It includes bio-based fuels and materials that take advantage of the tremendous agricultural capacity in the United States. It includes more energy efficient buildings. If we can combine some novel materials with systems engineering design, we can produce buildings that are more energy efficient, more comfortable, and more affordable. We need transportation that's electrified, that makes use of lightweight materials to improve energy efficiency. And we need to think about how we can optimize the use of our resources to move people around in a way that is comfortable, safe, and has minimum impact on the environment. 80% of our primary energy comes from fossil fuel, and there's no way to get away from the fact that there are CO2 emissions associated with burning coal, gas, and petroleum. We need a better understanding of what's going on with the climate. Fortunately, we have some great tools. We can measure what is going on in sensitive ecosystems in the Arctic. We can also use our supercomputers in order to model in a way that's not just projecting weather a week from now, but it's how things will evolve over decades or even centuries. Through ongoing collaborative relationships with more than 800 companies, Oak Ridge is also working to advance manufacturing in the United States. We contribute through the development of new energy-efficient manufacturing technology, 3D printing, chemical separations, and unique diagnostics like electron microscopy. There was a time when the national lab focus on global security was really around nuclear weapons. That's still an important problem, and nuclear proliferation is a threat that's probably as acute today as it's ever been. But the 21st century global security challenges are a little bit broader and require a different set of tools. It includes cybersecurity. If you think about the vulnerabilities of the electric grid and what that could mean for an advanced society, you have to be concerned. High-performance computing is potentially part of the solution. We're also developing new science and technology to detect, verify, and track nuclear materials in nations all over the world to keep them out of the hands of our adversaries. And we're helping to ensure that our military and intelligence personnel have the most advanced technology available. New types of lightweight armor, surveillance sensors, big data analytics, and remote explosive detection systems are among the products created as ORNL scientists and engineers leverage their know-how to help defend the United States. The vast majority of the funding that we receive is from the taxpayer. We're funded on the basis of a promise that we make, that the research and development we do at the lab will have an impact on society. Tech transfer is the way we do that, working with industry, getting our research deployed, getting it into the hands of entrepreneurs, and also working with students, whether it's undergraduate students spending a summer here or graduate students who may be doing a lot of their thesis research, working with laboratory staff, working with our facilities. We're not trying to solve every problem, but the ones we're trying to solve are fiendishly complicated. They require teams of people with expertise across a broad range of discipline, working together in a pretty focused way, but in an environment where they can still explore creative solutions. It doesn't happen fast, sometimes it takes years, but we have a well-deserved reputation for solving those fiendishly complicated problems. At the beginning of last century, there were predictions of catastrophe because of growing population and food scarcity. The projections weren't wrong, they just failed to anticipate the breakthroughs in science and technology. So we know that if we apply ourselves to the problems we face and we push the development of new materials, neutrons, computing, and nuclear, that we can solve the energy challenge, we can avoid the unpleasant global security consequences, and we'll be doing breakthrough Nobel Prize winning science. Our science and technology agenda is a living document. It will evolve, missions will evolve, and the opportunities will change as one breakthrough leads to another. We need to make sure that we sustain and strengthen our capabilities and apply those to the world's most pressing problems.